Okay, let's begin section 1.6, which is division with whole numbers. And remember, we were talking about this before, where you can write division as either the symbol, one over the other, like as in a fraction. We sometimes use this slant, A divided by B, and then the quotient of, okay? So let's say, for example, here, quotient is also the parts of the quotient is the answer when a divisor divides a dividend. So what is the quotient? So here, 10 is being divided by 5. In this case, 5 would be the divisor, right? And the dividend would be 10, and the quotient would be 2. Okay? All right, let me put this page. Okay, words that describe, I don't know why that didn't print out, division. So what are they? We can rewrite these using symbols. So let's go ahead. The quotient of 15 and 3, we can write this as 15 over 3, which is 5. The quotient of 3 and 15 would be 3 and 15, which simplifies to become 1 over 5, right? If you divide by 3 top and bottom, that's how you simplify fractions. The quotient of 8 and n, 8 over n. X divided by 2, we can do x over 2. That's the more common way of writing it as in fraction form. And to write the quotient of 21 and 3 is 7. So remember that the is represented by the equal sign. Okay, what's the relationship between division and multiplication? So let's think about this. When you have 18, notice the following. 18 divided by 6 is 3, since 6 times 3 is 18. Okay, so let's do some examples. So notice the following. 15 divided by 3 is 5. Okay, this also can, if you know this, you can also state that 5 times 3 is equal to 15. So you see how they're kind of related? You can, there's a lot of reasons why we can explain this, but they basically have, this is like the inverse operation. So they're connected, okay? So let's do another one so I can prove my point. 15 divided by 5 is 3. Okay, so, and then we can also say that 3 times 5 is 15. Okay, so maybe you can try a couple on your own, make up some, and notice that there's this relationship between division and multiplication. In other words, they're inverses of each other. When we say they're called inverse operations. Just like how addition and subtraction are inverse operations of each other. They undo each other, right? Okay, so next thing about division, let's do some long division. Yay, smiley face. So let's try dividing by a single number. So 465 divided by 5. So remember how this goes. 5 doesn't go into 4, but it does go into 46 9 times at least. So that 9 times 5 is 45. Subtracting, we get 15. 15 goes into 5 goes into 15 3 times. 3 times 5 is 15, and that is it. So our answer is 93. So now you try. Here's a couple. 595 divided by 7 and 7,650 divided by 7. Go ahead and push pause and try these out, and then we will go over them in about 10 seconds. Okay, so for the first one, I'm going to write it over here. We're going to do 7 goes into, or 595 divided by 7. So again, how many times does 7 go into 59? We look at these two first. And it's really good to remember your multiplications, right? Your multiplication tables. So 8 times 7 is 56, right? And then we subtract. So this comes down, this becomes 35. 5 goes into 35 exactly 5 times. So that's nice. Okay, let's do the next one. We have 7,650 divided by 7. So it goes into 7 once, right? Okay, but we still have everything left over, 650. 7 goes into 65. It doesn't go into 6, so we put a 0 here, placeholder. 7 goes into 65 how many times? Well, 9 times 7 is 63. We know that. So subtracting, we get 2, bring down the 0. 7 goes into 20 2 times, right? So then that becomes 14. And we have 6 left over, so that just becomes 6 over 7. Okay? So that's one way. So 1,092 and 6/7. Sorry, let me go ahead and show you that. Sorry, I thought you could see it. So, alrighty. So let's go ahead and do another one. What if we want to divide by multiple numbers or multiple digits, right? So let's say we have 35 going into 9380. And it's important, you might think like, well, I have my calculator, why do I need to do this? We're going to be using long division at some point. I don't know if it's the end of this course or the beginning of college algebra, but you will see this with variables. So it's really good to know this process. Okay, so 75 goes into 93 twice, at least, right? So that's 70. Subtracting, that becomes 238, 0. 35 does not go into 23. In fact, it goes into 238. How many times? So if I try to guesstimate, right? So you know it's going to be less than 10. You know, because 10 times 35 would be 350, and 9 would be too big for our purposes, right? So we're going to have to try 8 would be too big also, because 8 times 3 would be 30 would be 240. So what about 7? Would 7 work? What would 7 times 35 be? So let's try it. 35 times 7. So 35 times 7 would actually be too large as well. So then we'd have to do 35 times 6. So we do 6 here, so that becomes 210. Okay, subtracting, we get 2, 8, and then 0. So 35 goes into 280 exactly how many times? So 35 goes into 280 how many times? It actually goes in exactly 8 times. So that's it. So that's your answer, 268. Now you try, go ahead and push pause and try this. And okay, so let's see if we did the same thing. 18 goes into 18 once. Right, bring everything else down. We get 72. 18 goes into 72 how many times? So it actually goes in, 18 goes into 70 times, but 18 goes into 72 4 times exactly. So, right, so that's it. Okay, so if you got 104, give yourself a pat on the back. There you go. Okay, let's do some more super fun examples. Sometimes these long division problems have remainders. We did one earlier, but let's go ahead and do another one. So 67 does not go into 16, so we have to think about how many times does 67 go into 169. Okay, so it's about 2 times. So 2 times 67 would be what? So 4, 1, so 134. Then subtracting, we would get 350. And then 67 would go into 350 how many times? About 5 times. So we go ahead and do that. So 67 times 5 would give us 5, carry the 3, 335. And then subtracting, we would get becomes a 4. You borrow 5, 1, 15. So our total, our final answer would be 15 over 67. So 25 and 15 67ths, okay? Or you can say, you say 25 remainder 15. That's another way of doing it. But I prefer this way because we're going to use this later, so this is kind of like an older way to do it. Okay, so now you try, go ahead and push pause, and then I'm going to give you 10 seconds, and then you can try it. Okay, cool. So we set that on the outside, 12, dividing into 35,880. Okay, so 12 goes into 35 twice. That's 24, right? Bringing that down, that's 11, 8, right? The whole thing, 80. 12 does not go into 11, but 12 goes into 118. Let's try 9. So then that becomes 8. Carry the 1, and that's 108. Okay, and then we subtract that. That gives us 1080. We bring down the others. So 12 goes into 1080 exactly, right? Because if we ignore the 0, we know that it goes in 9. So that's 108 here. Sorry, this is a 0. And then subtracting, this 0 just comes down, and your remainder is 0. Okay? So then this is a 0 as well. So let's see here. So your answer is just 2,990. Okay? Good job. Okay, now let's listen to this. So what's the difference between dividing 0 by a number and dividing a number by 0? Which one is allowed and which one is not, and why? Okay, so suppose you take 0 and we divide it by 5. We take nothing, we split it up into 5 pieces, and that is 0, right? 0 divided by anything is 0, okay? Now, this, however, is impossible. You cannot take a number and divide it by 0 and get some other number, a non-zero number, okay? So, how can I prove this to you, okay? So, let's suppose that we could do that. Let's suppose that you can divide by 0, okay? Let's say you could. So let's take some number, a that's not 0, okay? We're dividing by 0, and let's suppose that this exists, okay? If this exists. And if this was true, then I could multiply both sides by 0 according to inverse operations, and I would cancel this out. I would get a is equal to some non-zero number would be equal to b times 0. But wait a minute, that's a contradiction because we just said earlier that 0 times anything should be 0. So a does not equal 0. So therefore, you cannot divide by 0, okay? It's kind of a little proof by contradiction. So the point is, we know that we can divide 0, but we cannot divide by 0, okay? So that's really important. So this is okay, and this is not okay. Okay? All right. And that's it for this section. Your super fun homework is 1.6, 1 through 72, every other odd. And the secret word this time is divide. So creative. Okay, see you guys on the next video.